Dan, it's fantastic to be sitting here with you today. It's truly an honor to have you with us. Thank you for joining us. And I also want to add to that already amazing introduction, the fact that we really are standing on the shoulders of giants, and you're the giant, because we're using BLS all over the place. So thank you for making BLS, and so many other protocols that you've worked on. And also want to point out that Dan's been pioneering a lot of work on VDFs, which are sort of around the corner for Filecoin and Ethereum 2 and a number of other things. There are proofs of replication that he's worked on, and also the single secret leader election protocols and much more. And really, as Colin said, thank you so much for helping us over time to build Filecoin. Your advice over the years has been super helpful. Great. So with that, today we'll just kind of walk through a few topics together. We'll talk about Web3 technology, and we'll kind of dive into blockchains and kind of important cryptographic protocols there. We'll talk a bit about Filecoin, and then we'll maybe spend most of the time thinking about the frontiers for both blockchains and Filecoin, and what kinds of interesting cryptography areas we might spend some time in. And if there's time, we can spend perhaps a bit of a few minutes on Web3 values and things around kind of encryption and user control and so on, or potentially blockchain education, which I know you're a great proponent of and one of the main teachers of blockchains in the world. Great. So with that, kind of, I was curious what when blockchain first started, there was this kind of gap between sort of the parts of industry that really were willing to kind of embrace and think about blockchains, and the rest of industry, which sort of really ignored it and sort of thought it was dumb or stupid and so on. And a similar kind of story played out in academia for some time. It was sort of seen as kind of old news. Cryptocurrencies had been around for a long time. Bitcoin seemed to be just another cryptocurrency that was probably going to fail. But a few groups, and I think you are among those groups, really saw more into it and started very early on kind of to inspect the work and actually dive deeper into the system. So I'm curious what kind of attracted you to the space, and now what fueled that.
Absolutely. Thanks, Juan. Happy to address that. So first of all, I really want to congratulate the Filecoin team on the launch. It's an amazing achievement. Maybe we'll get into this a little bit later, but it's really quite remarkable how many cryptographic tools went into Filecoin, and to see that all coming together and launching is just remarkable. Maybe later I can just kind of quickly go through the list, because it's really quite impressive. So congratulations, Juan, and congratulations to the whole team. And thank you so much for inviting me to speak here. It's a wonderful event, and I'm really excited to be speaking here. So let's see. So what attracted me to the space personally is it's primarily the fact that it's successful. Yeah? I mean, so not only that, it's basically an amazing testing ground for deploying new cryptographic systems, cryptographic tools. So what's happened over the years is on the internet, it's become very difficult to deploy new cryptographic systems. I think actually the networking people kind of observed this too. So every time there's an idea for a new networking protocol, it's really difficult to get new networking ideas deployed on the internet, because it's kind of ossified already, right? It's very difficult to make changes. Same thing with new cryptographic schemes. It's very difficult to get them to actually be deployed on the global internet. Whereas in the world of blockchains, things move so much faster. It's amazing. Yeah, the rate of change in blockchains is remarkable, where all of a sudden ideas that have been around for many years that nobody was able to deploy them on the internet, all of a sudden we're getting deployed like left and right on in the blockchain space. So personally, that's what attracted me, that finally we have like an opportunity to kind of show that all the amazing crypto that's been developed over the last 20 years is really useful for things, that if you just take the time to deploy them. So to me, that was like really exciting. And I'm really thrilled to see like protocol labs, deploying things like BLS signatures, and obviously proofs of replications, and depth robust graphs, and vector commitments, and beacons, and verifiable random functions, and snarks, and it's amazing the number of tools that just came together in Filecoins is just unbelievable. Yeah.
So yeah, we have the entire zoo of cryptographic protocols in Filecoin. Yeah, curious what you see as a cryptographer looking through Filecoin and looking through that collection. What kind of like is most interesting, or maybe what do you see as maybe a frontier for us where we might end up kind of reshaping pieces or things like that.
Oh, so where things are headed. Yeah, so I think there's still a lot that cryptography can do. There's a lot of cryptographic research that hasn't been put to use yet. So there's still a lot coming. Maybe I could just mention a few things that are kind of interesting to us and see, some of them honestly are maybe a little bit further out, not quite ready to be deployed, but still kind of interesting things to keep in mind. So one question is always, can you keep secrets on the blockchain? Can you have like a program running on the blockchain, a contract or an actor in the world of Filecoin that actually maintains secrets, and even though it's maintaining those secrets in a sort of a publicly executable environment, nobody can abuse those secrets. So often that goes under the heading in cryptography, that goes under the heading of code obfuscation. Effectively, can we kind of obfuscate enough that we can keep a secret in code that the code can run, but nobody can extract the secret and use it in ways that it's not supposed to. So that would be quite interesting if we could do that. Right now, we're really, honestly, the crypto community is really only the beginning of applications of code obfuscation. So that's not something that's quite ready to be used yet, but maybe in the future we'll be able to. A couple of things that I'd like to mention that are kind of relevant to Filecoin and probably we're going to see used in the future are things like effectively Filecoin is implementing what's called access control by encryption, right? So the way we control access to data is basically by who has keys to decrypt that data. Well, so the question then is who should be given the keys, right? How do we do, so access control shouldn't really mean that all keys are created equal, right? Maybe some keys are able to decrypt some files and other keys are able to decrypt other files. And so there's a lot of questions around access control by encryption. For example, if I give you a key and then later I want to revoke your access to that file, how do I do that, right? How do we do that? And so I did want to mention a couple of interesting directions in that, a couple of interesting kind of techniques in that area, just in terms of revoking access. Once I give you the key, how do I revoke access? The typical way to do that is using re-encryption, right? I would re-encrypt the file under a new key, and that makes the old key sort of useless. But if you think about the context of Filecoin, or even more generally, data stored in the cloud, re-encryption is pretty expensive, right? I have to kind of download the data, re-encrypt it, upload the data. And so I did want to mention like an interesting crypto primitives that's fairly recent. I think it's like a couple of years old, called updatable encryption that actually allows you to do key rotation in the Filecoin network without actually touching the data explicitly. Yeah, so updatable encryption, this is a well-defined concept. People can Google something called updatable encryption. What it allows you to do is take the old key, take the new key, and generate some sort of an update token from that. Then you would send the update token to the miners, to the storage providers, and then the storage providers will be able to run on the encrypted data and kind of do the key rotation on the encrypted data, even though they themselves don't know what the old key is or what the new key is. Yeah, so that's a sort of way that's a sort of way to revoke access very cheaply after a key was given out.
That's a particularly important area of things because as we head into any kind of decentralized application or especially in a world with many users, you have groups of people interacting together over data sets. And these groups of people are generating data and pieces of data and contributing them to these kind of accreting graphs of data. And over time, we add more people to a group and remove people from a group. And so there's all kinds of hard questions that come in when do you have to re-encrypt or update the encryption of a stream of updates and so on. One of the things that makes this particularly difficult is the world of CRDTs. So certainly under consensus and maybe in the Filecoin world, we can rely on the fact that we have consistency over the world. So we can update in one place and maybe that's it. But some of the applications that Web3 has and certainly will be kind of used in conjunction with Filecoin are applications that are fully in a distributed environment and can't really rely on any kind of notion of consensus. Have you encountered this kind of problem and access controls or in that kind of a permissionless or decentralized environment? So this would be kind of access controls over CRDTs.
So let's see. So how do you do? So you're asking how do you do access control when there's no central entity?
Yeah, when you have kind of like this, eventually consistent, convergent data type that is exchanging updates, and then suddenly, one group over here can talk to each other, another group can talk to each other. They have the same data set. Maybe there's some revocations that happen, and now you have to merge those updates. And so that particular problem we've encountered a lot when we're thinking through things, applications like a document that's updating in real time with different groups. If you make that document update in real time with different groups in an offline setting, and you have that work in different offline settings, then suddenly you get into a whole mess when you try to apply replication.
Yeah, so I guess you're kind of asking, it's not just so much about access controls, basically how do you merge, like when you have conflicting updates, and right, that's kind of getting into that as well.
Yeah, exactly. All that merging is we have a lot of really good algorithms for that, but they all completely punt on encryption completely. Like they're just all assume that, or most of the algorithms assume that everybody is allowed in.
Yeah, I guess a lot of these questions can be solved using actually, I have to say, another tool that I think is going to play a major role in blockchains in the future, but it hasn't played a major role so far, which actually has to do with multi-party computation, right? MPC. So when like multi-parties have to deal with data that they don't want the world to see, and they don't want even each other to see, so different parties control different parts of the data, for example. You can still run a protocol among these parties to do updates, to make sure that the proper rules are being followed on this data. And so what you're describing specifically for CRDTs, I think actually that's a pretty fertile playground for multi-party computation techniques. And so yeah, I think that actually is something that it's kind of interesting, yeah, that zero knowledge techniques and snarks and all that, those have gotten a lot of use in blockchains for obvious reasons. It's quite interesting that multi-party computation hasn't quite come into maturity in the world of blockchain. But that actually is probably something that's coming. Yeah, so I think the audience does need to be aware that these techniques are out there, right? So we can have a large number of people each see one aspect of the data, so they don't see the whole picture. And even so, they can kind of compute a function, compute a program on the collected data that they all own. Yeah, it's kind of amazing if you think about that nobody knows the full data set, and yet you can run, like each party knows only one part, and yet you can run a large program on the combination of the data that they own, and reveal nothing about, and nobody learns anything beyond what they're supposed to learn. Yeah.
This seems like a phenomenal way to do all kinds of computation and verifiable computation, or in an environment where you have an untrusted cloud, say of computing providers. So imagine like the storage providers are also computing providers, and you want to run a function over the data that you've hired the storage providers to store. So now you want to be able to run that function, but ideally you don't want to reveal the plain text and reveal the actual original data to the storage provider. So being able to run that computation with secrecy would be ideal. Do you see MPC as being like one of the tools in the toolbox there, or is there kind of like some efficiency problem there where that might be some other techniques?
Yeah, so right, no, absolutely. So the only issue with MPC is that it scales quadratically with the number of participants. So it's not going to grow to a very large number of participants, but as long as the number of participants is moderate, definitely that's actually something that we'll likely see in the future too. Maybe I wanted to mention a few other things that we might be seeing also in the future. So other primitives. So Filecoin, for example, uses Merkle trees all over the place. Yeah. It's interesting also, Merkle trees and vector commitments and such. So one thing that, and then Filecoin does a lot of zero knowledge proofs on top of these Merkle trees and vector commitments. So one interesting thing is that there's, I think many in the audience probably know this, there's a competing technology that allows you to replace Merkle trees with these things called accumulators. And when it comes to do proofs on Merkle trees, sometimes doing proofs on accumulators actually can be more efficient. Yeah. So when it comes to vector commitments, that's not quite the case. But more generally, if you just want to prove that you're in zero knowledge and your data is part of a larger data set, an accumulator can often do that more efficiently than a Merkle tree. Yeah. So that's also something that we don't see being used as much. Merkle trees kind of are the things that's kind of deployed everywhere. But again, I want to mention, just because blockchains are such a wonderful playground for new cryptographic techniques, that's actually something to consider. Yeah, that there are other Merkle trees are not the end all way to commit to a set and then later prove membership. There are other ways to do it, especially when you need to do zero knowledge proofs on the set. There are other ways to do it that are more efficient in a Merkle tree. Yeah. So.
Yeah, that's fascinating. And I think it definitely will be, as people become more familiar with the tools, that will very likely propagate to a bunch of different systems all over the place. Quick question that brought up: do you think that blockchains will remain chains? Meaning, right now we come from a world of the Bitcoin style blockchain with chain transactions. We moved to sort of the account model of Ethereum, with being able to kind of compute in place. We now have a lot of different blockchain designs, where some are in kind of the path to scalability are sharding chains, and that could be recursive all the way down to, you can think of a hierarchical tree with taking into account the topology of the internet or something like that, to get into consensus trees that are really, really small and granular. And so no longer do you have like a set of chains, but not necessarily one single chain. And there's a whole other direction where people are going, where you get rid of the chain. You just have the latest block, and you have a proof that all the transactions that you've processed have been correctly computed, and then you can throw away the history entirely. These are two kind of things that are being tried. They can be combined as well. And so to me, it seems that the blockchain itself will lose the chain, and we'll end up with a block. But I'm curious if you've thought about.
So you're talking about projects like Coda and such, right? So look, I mean, those are beautiful, beautiful ideas, right? It's kind of, again, it's this is why this area is so much fun, right? I mean, Coda, what they're deploying is like again, an amazing idea, where the whole, as you say, the whole chain is reduced into one block. But even though you need this one block just to verify that the current state of the chain is correct, if you wanted to recompute things, you still need access to previous data, right? So, I mean, the data availability is still going to continue to be an issue, and so on. What can I say? I mean, of course, I hope this is where things go. Although honestly, the bigger issue, I think, is not so much the actual design of the chain. I think there's a much bigger much bigger concern that we should worry about, which is the question of whether the chains themselves are open to the world or whether the chains themselves are closed. Yeah, so I'm a little bit worried that obviously there's a lot of discussion in the context of central bank digital currencies and so on, where the discussions are around closed blockchains. So these are blockchains that I differentiate that from permissioned. These are, when I say a closed blockchain, what I mean is that the data on the chain is only available to a select number of organizations. Yeah, and that, unfortunately, I think defeats the whole purpose of what our community is trying to do. Right, the whole point of blockchains is that the data is public, so we have universal verifiability and we have interoperability. Yeah, so it's absolutely critical that this is like one of the things that we should kind of insist on and say as loudly as we can, that data on the blockchain should be made public for everyone to see. And by the way, that actually raises these beautiful, beautiful questions of, I mean, clearly people still need privacy. Yeah. So if the data on the blockchain is public, how do you achieve privacy? And that brings up the whole question of private transaction on a public blockchain, right? Which we know how to do. It's counterintuitive. Again, it's something that we need to explain well to the public. It sounds counterintuitive, right? If the blockchain is public for the whole world to see, how do you have a private transaction then, right? If you have universal verifiability, how do you have private transactions? And of course, the whole world of zero knowledge and snarks and such allows us to do that. So to go back to your questions, Juan, I'm less kind of focused on the specifics of the actual chain structure we're going to end up with. I think we're going to see lots of experiments, and the market will choose the one that actually wins. But what we should insist on as a community is really that the data on the blockchain should be public for everyone to see. So we don't give up on public verifiability, right? And of course, that then raises the whole question of private transactions on a public blockchain. So it's a great question. And I really hope we kind of can maintain the public aspect of the chain.
Yeah, we will push very hard on that, and hopefully we'll provide enough data storage to the world that they can just put all the data there, so they don't have to worry about blockchains getting large. So one other question I kind of wanted to ask was around Filecoin right now is using DRAND, and DRAND is using BLS to produce a randomness beacon, and that was a very important decision in our trajectory because it vastly simplified a lot of the kind of randomness questions in the protocol. So when you're trying to do something like a proof of stake oriented consensus protocol without a randomness beacon, and you're trying to build the randomness within the protocol, you end up with a very, very complex system. So we sort of made a decision that for simplicity, blockchains will likely head towards a world where there's some tiers and there's some randomness beacon somewhere. And so we invested a lot of energy and resources in building out the DRM protocol that already existed at a really phenomenal project, and kind of got it to production readiness and so on. At the same time, we're also kind of already thinking of kind of where that's going to head in the future, especially as we get really high, good VDF hardware. So once we have the ability to have VDFs and randomness beacons with VDFs, we might be able to kind of update or upgrade or create new randomness beacons with that. But either way, it seems like we're in a moment where we might be able to produce a single randomness beacon for the internet, kind of like NTP. So we have a single protocol for time. Why not make a single protocol for randomness? And it seems like we are kind of close to that. I'm curious if you have any thoughts or advice on how groups like us and others can help push on this to kind of arrive at a good unbiasable randomness protocol for the internet.
Yeah, so you're asking me about DRAND and VDFs. Obviously, I like VDFs, verifiable delay functions. So I hope we want to see more use of those for sure. So that actually makes the beacon design relatively simple, right? Relatively straightforward, and so that seems like a perfectly good way to go. Beyond that, it seems like you're asking how do we? I agree. I mean, we are at a point where we might get a beacon for the internet, which is kind of a useful thing, and everybody can trust that beacon. I guess we've had beacons before, like the NIST beacon, but how do we know that the NIST beacon really isn't biased, right? It's kind of difficult to verify. And we are at a point that we might be able to build one for the internet. And so what can I say? I mean, what you guys are doing is right on target. So but honestly, this is kind of an area where it's good to to involve the standards bodies. So if the IETF can come up with an RFC for how an internet-wide beacon might look like, I think that's kind of the next step, right? And obviously there are multiple techniques for building a beacon. I guess you guys chose one, I guess threshold BLS, which is great. There are other approaches like the VDF approaches and such. And so, I mean, the next step, I think the next step is to try and standardize. And once we have standards, then people can go ahead and deploy. Yeah. I wish I had a more technical answer.
That's good. No, that's good. And often, all it takes is a steady progress on the standard way of deploying protocols on the internet. It just takes a while, but eventually you get there. It took us about 4 to 5 years to get IPFS into browsers, but now it's there, right? And so like that's a good good place to
start somewhere, right?
Yeah. So maybe last question. I know you probably have to go soon. I know that you are very last couple of questions. You're very into blockchain education. You've and just crypto education in general. You wrote a crypto textbook. You've given your crypto classes over at Coursera. A lot of us have learned crypto from you in various different forms. So thank you, first of all. You've helped us understand a lot of cryptography that would have been very difficult otherwise. And second, what do you see ahead? What do you see ahead in the world of education for crypto or blockchain specifically?
Yeah, that's a great question. So first of all, we've been teaching our blockchain class now for many years. I think I taught it the first time with Joe in 2015 or so. I have to tell you, teaching blockchains is like one of the hardest classes to teach because literally the class changes completely from year to year. Yeah. So in the first years, literally we were rebuilding the class from scratch every time. One thing I'll say is that if there are any faculty out there in the audience, this is a lot of fun to teach blockchains. I highly recommend it. The students love it. We've been teaching it now. This is what, the 7th year or so that we're teaching it, and every time we teach it, there's over 100 students who enroll. So even though this is like this niche kind of, it doesn't satisfy any requirements, still 100 students enroll. So this is kind of a big deal. And these are computer scientists, right? So these are computer scientists that when they graduate, they go work in the blockchain industry. And so it's kind of an important activity, so that the ecosystem has a constant supply of developers. But it's also kind of really interesting to teach. I think we finally hit the right set of topics that should go into a blockchain course. So if anybody's interested in looking at what we're teaching, just check out our CS251 class on the Stanford course. It's the syllabus is open. All our projects and homeworks are open. So please go steal everything we do. Feel free to use it. And by the way, if you want to just challenge yourself and just see if you how well you know the area, just go do our programming projects, right? Everything is open source. So just go ahead and do it. Try to do our homework problems. Just hopefully you will learn from that as well. So I think that, like I said, the area is, first of all, it's very interesting to undergraduates. Yeah, they keep coming to the class. It's a lot of fun to teach. It's a lot of work, but it's a lot of fun. Like I said, I think we finally know how to structure a course like this. So if anybody wants to teach a course like this at their own school, or maybe even record a MOOC on blockchains, yeah, that's I think this is a good way to organize it. I think we're getting, in the first couple of years, there was no point in doing like literally a blockchain MOOC, because the field was changing so rapidly. Interestingly, things are starting to converge, yeah? And so, the general buckets, scalability is kind of a topic on its own. Privacy is a topic that can be discussed. The economics of blockchains is a topic that can be discussed. The crypto that goes into blockchain is a topic on its own. So there are like these buckets are starting to form. And so we kind of know what are the areas that need to be hit. And yeah, Will is asking, yeah, this class is CS251. Just go to cs251.stanford.edu and you'll find it. Yeah, please go ahead and teach one of these classes yourself, and try to
That's
do
super useful. I wonder if we might try to do that remotely and see if we can do a virtual class. I think that might be a pretty interesting thing. We tend to be a pretty open community, and we do a lot of learning with a lot of different folks. So we might try that out and see how it goes.
And by the way, I do have to mention that today we actually have a guest lecture. Like literally, when I log off here, I'm going to go to the class. We have a guest lecture from someone from Filecoin about regulation. Yeah,
Yep.
Yeah.
Phenomenal. So last question. And by the way, if you have to run another class is starting, feel free to say so. Otherwise, in 15 years, what will you look back on as the most significant achievement in computing? This is one of these questions that you might have a prescient view that many other people don't know, or you might be looking at a certain area that is very interesting and very changing very quickly. And so I'm always curious about that kind of question.
In computing in general, or just in blockchains?
Computing in general. So when you look back and you think between machine learning and all of those environments, what across computing, what do you think will be the most important achievement?
Oh my God, that's a difficult question, huh? I mean, look, obviously machine learning is going to have a big impact on our world, but I guess we should stay in the realm of blockchains and cryptography. I think if we are able, in 15 to 20 years, we make life better for people, that would be obviously that's the ultimate goal. I think one way to make sure life is better for people is to make sure that your thoughts are not being policed, and what you tell your close friends is not being policed. And basically just, private conversations are kind of the bedrock of civilization, right? It's very difficult to have a civilization if you and I, Juan, can't talk privately without fearing that someone else is listening, right? If we did worry about other people eavesdropping on everything we say, then we would self-censor ourselves. Yeah, so I would like to think that, in 20 years from now, if we are able to make sure that, we don't have to constantly self-censor ourselves. So you and I can have a conversation without, even though we're far apart, we can be sure that there are no eavesdroppers. I think that would be a big win, and I think it would be quite important for society. Yeah.
Thank you. Let's make that happen.
Yeah.
Dan, thank you so much for joining us. It's been a true honor and pleasure to have you with us. Thank you again for all of the help that you've given to the Filecoin project. We wouldn't be here without you. So thank you so much. And take care.
Likewise, Juan. Thank you so much, and congratulations again for making this happen.